Hello, good afternoon students. Welcome to the session. This is Suresh, Faculty of Chemistry from Infinity Lane by Sri Chaitanya. How are you all, my dear students? Richa Sharma, good afternoon. KV, hi. Great to see you all guys waiting for me. I just joined a couple of minutes late for today's class. How are you all? Fine. So, welcome to YouTube channel NEET STEP UP 2025 program. Here in this NEET STEP UP program, we are offering from Infinity Learn side. So, on the YouTube platform, right from 12 o'clock afternoon to evening 6 o'clock, physics, chemistry and biology, and total 11th and 12th syllabus is going to be covered. So, you please join in these sessions on a regular basis. If you are not able to join in a live session, you please watch the recording even, so that you can also ask your doubts in the comment box, so that these comments are going to be addressed. Okay, you also share, like and subscribe this YouTube channel and get use of these lectures, which is absolutely free for your friends also. Hello Ishita, okay, Rashan, good afternoon, nice to see you guys. So today is a lengthy lecture here almost. We were just about to discuss about Bohr's atomic theory. Today we will do that. Fine, that's great to see. Fine, good. So welcome to the session. Here what we learned in the previous class. We learned in the previous class many things: fundamental particles, Rutherford model, nature of light, hydrogen spectrum also. Hydrogen spectrum has various spectral lines, Lyman, Balmer, Paschen, bracket series, right? Okay. Now, what we are planning in today's class, about atomic spectra of hydrogen. We are going to continue here, and Bohr's atomic theory, and we will also discuss de Broglie as well as Heisenberg if time is provided, right? Okay, Richa, come on. So, let's see, the fundamental particles is completed. Bohr's atomic theory we need to start. Before Bohr's atomic theory, we need to talk about hydrogen spectrum. Before hydrogen spectrum, I just want to give a key point about photoelectric effect. Why? Because Bohr's atomic theory was based on photoelectric effect and Planck's constant, right? Planck's quantum theory. Ishita, fine, let's see. So, photoelectric effect. What is photoelectric effect? When a light with a suitable energy falls on a clean metallic surface, electrons are going to be expelled. So, ejected you can say. This phenomena is known as photoelectric effect. In this phenomenon, when the light of a suitable frequency or energy, what is light? Light is a packet of energy. When this packet of energy strikes the electron inside the atom, the absorption of energy by the electron takes place, so that फिलहाल a electron nucleus से जोड़ी किया electrostatic force of interaction से, so ये तोड़ के electron बाहर निकल रहे हैं. So this is called photoelectric effect, and this is the one Einstein photoelectric effect equation. Rathod, hi, Parth Rathod. So E is incident light energy, E naught, or W naught, you can say work function, the minimum amount of energy that required to cause a photoelectric effect, and Ke is the photoelectron kinetic energy. E is equal to h nu, where nu is the incident light frequency and W plus Ke. So you can also say W is equal to h nu naught. Nu naught is nothing but incident light, the critical frequency or threshold frequency. समझ में रही क्या बेटा? So the minimum frequency that can cause the photo ejection. So we can say h nu is equal to h nu naught plus Ke. So that Ke is equal to h nu minus h nu naught. So we can write Ke is equal to h common निकाल के आपका आएगा nu minus nu naught. So this is very important equation. cheat sheet में बनाओ आप लोग. So कल यहाँ तक हम डिस्कस किया है ना? कुछ डाउट है ना तो पूछना. ओके, ऋचा, इशिता, पार्थ राठौड़, नाइस. Okay, let's talk about stopping potential also we discussed by using a photovoltaic cell. The minimum potential that is required to stop the electron, photoelectron, is called stopping potential. When the photoelectron is stopped, iska kinetic energy zero hoga. So half mv square is equal to EVS. VS stands for stopping potential. So अगर स्टॉपिंग पोटेंशियल में काइनेटिक एनर्जी वैल्यू कम से कम 0 होना है ना बेटा? रोहित सिंह, हेलो बेटा. सो we can go ahead with spectra, atomic spectra, hydrogen spectra. We discussed emission spectra, spectrum obtained by the emission of radiation. It could be continuous spectra or it could be discontinuous spectra. Continuous spectra means continuous array of wavelengths. It's a short recapture that happened in yesterday's class. Yes beta. So and this, when the light is fall on a prism, it is going to give violet, indigo, blue, green, yellow, orange, red. So this सुरेंद्र चटर्जी फोटोइलेक्ट्रिक इफेक्ट, और एक बार आपके लिए चटर्जी सिर्फ आपके लिए. इफ एनी स्टूडेंट आस्क ए गुड क्वेश्चन or a valid question, I am going to repeat it, doesn't matter for me, right? Okay, so let us talk about the photoelectric effect. So I just want to recall what is photoelectric effect. Okay, Ayush Kumar and Chatterjee, that's good, that's good. So सिर्फ आपके लिए देखो बेटा, देखो, you take a clean metal surface बेटा, this is a metal, है ना? उसमें हाँ उसमें अगर लाइट इंसिडेंट किया गया तो दिस इज ए लाइट, है ना? सो लाइट इज ए, लाइट में क्या एनर्जी है, ये एनर्जी का वजह से ये मेटल जो एटम्स होते हैं ना, उसी से इलेक्ट्रॉन बाहर निकल रहे हैं. सो दिस इज व्हाट यू कॉल इट एज अ फोटो इलेक्ट्रिक इफेक्ट. यस, थैंक यू केवी. सो व्हेन a light with suitable energy falls on a clean metallic surface, ejection of electrons takes place. This phenomena is called as photoelectric effect. So उसमें क्या कर रहे हैं? So ये मेटल जो है ना, ये मेटल में क्या होगा? मेटल एटम्स होता है बेटा, मेटल एटम्स होता है ना? So मेटल एटम में और क्या है? न्यूक्लियस एंड इलेक्ट्रॉन. ये दोनों के बीच में क्या होगा? दोनों के बीच में अट्रैक्शन फोर्सेस होता है. सो व्हेन ए लाइट, यू जस्ट से ए लाइट, ये लाइट में क्या एनर्जी पैकेट, ये पैकेट ऑफ एनर्जी क्वांटम थ्योरी का हिसाब से लाइट इज ए फॉर्म ऑफ एनर्जी, इट प्रोपगेट इन द फॉर्म ऑफ पैकेट्स, राइट? सो दिस इज एनर्जी पैकेट. उसमें क्या होगा? सिर्फ एनर्जी होता है, उसका मास नहीं होगा. एंड पैकेट के बीच में थोड़ा सा गैप भी होता है. सो डिसकंटिन्यूस एनर्जी पैकेट. समझ में आ रहे क्या? ओके, थैंक यू वेरी मच. जब ये एनर्जी पैकेट इलेक्ट्रॉन को बॉम्बार्ड करने है तो सो इलेक्ट्रॉन इमीडिएटली एब्सॉर्ब द एनर्जी ऑफ द फोटोन. यू कैन से इट्स ए फोटोन और ए क्वांटम. सो तभी क्या हो रहा है? इलेक्ट्रॉन एक्साइट करके ये बॉन्ड जो है ना, ये तोड़ के इलेक्ट्रॉन बाहर निकल रहे हैं ना. सो दैट फिनोमिना इज कॉल्ड एज फोटोइलेक्ट्रिक इफेक्ट. दैट्स गुड. सो ये जिसका एनर्जी है, दिस इज एनर्जी पैकेट. सो एनर्जी ऑफ पैकेट, यू कैन से फोटोन, is used to break the nuclear force. फिर भी और कुछ इलेक्ट्रॉन बाहर घूमने के लिए इसका काइनेटिक एनर्जी चाहिए ना. सो काइनेटिक एनर्जी है ना, लॉ ऑफ एनर्जी कंजर्वेशन. दैट्स गुड केवी. सो एनर्जी ऑफ फोटोन आप ई से लिख सकते, द मिनिमम अमाउंट ऑफ एनर्जी दैट रिक्वायर्ड टू ब्रेक द न्यूक्लियर फोर्सेस ये इलेक्ट्रॉन ये न्यूक्लियस के बीच में कुछ अट्रैक्शन फोर्सेस है ना, ये फोर्स तोड़ने का कम से कम एनर्जी चाहिए। वो एनर्जी आपका बोलना है वर्क फंक्शन प्लस काइनेटिक एनर्जी। ये कौन बता दिया? मैं नहीं, आइंस्टीन बता दिया। ओके, सो E इज इक्वल टू इंसिडेंट लाइट एनर्जी, E is equal to incident light energy right, and W is equal to work function and Ke is equal to kinetic energy। समझ में रही क्या बेटा? चटर्जी, इज दैट फाइन? सो मैं क्या बोलना चाहता हूं, क्वांटम थ्योरी का हिसाब से E इज इक्वल टू एच न्यू, न्यू इज द फ्रीक्वेंसी बेटा। आयुष कुमार, गॉट इट, वेरी गुड, फाइन, नाइस। ओके, सो जब स्टूडेंट एक डाउट पूछेगा ना, हमको जोश बढ़ जाएगा। सो कीप द क्लास विथ लॉट ऑफ जोश बेटा। W इज इक्वल टू वर्क फंक्शन है ना, दैट इज इक्वल टू एच न्यू नॉट। ये न्यू क्या है, न्यू नॉट क्या है? न्यू इज इंसिडेंट लाइट का फ्रीक्वेंसी है, न्यू नॉट इज क्रिटिकल फ्रीक्वेंसी है। मिनिमम फ्रीक्वेंसी दैट रिक्वायर्ड टू कॉज द फोटो इलेक्ट्रिक इफेक्ट इज कॉल्ड क्रिटिकल फ्रीक्वेंसी और थ्रेशोल्ड फ्रीक्वेंसी और लिमिटिंग फ्रीक्वेंसी। So many nicknames are there. Simply you memorize as a threshold frequency beta, so that it is h nu is equal to h nu naught plus ke। So ke is equal to h nu minus h nu naught। Chatterjee fine, okay we fine, आयुष कुमार fine। So ke आपका मिलेगा h कॉमन निकाल के nu minus nu naught, बस समझे? रिचा, great to see that, very good, good। So Sushrutanda Chatterjee, are you there in the regular classes? Are there in the regular classes? Yes or no? KV? So what I request, what I suggest you guys is be regular in the class. So ये live session में है ना, so आप questions भी पूछ सकते हैं। If you pay thousands of rupees, lakhs of rupees, go to a coaching center, you can ask a doubt, sir may give the answer, may not give the answer, ये भाई YouTube session में आपको सभी फ्री आ रहे हैं ना। Okay, that's good. So let's talk about hydrogen spectrum. Hydrogen spectrum has, so spectrum, emission spectrum, continuous spectrum, absorption spectrum, emission spectrum, line spectrum or band spectrum, everything will be completed. So what is this hydrogen spectrum? Let's talk about the hydrogen spectrum here. Yeah, carefully you observe what is the hydrogen spectrum. It's very important. When the hydrogen discharge tube is taken, this is a tube light kind of thing, in that hydrogen gas is filled. It is connected to the electricity with high voltage. So what happened? The voltage is given, the energy given to the hydrogen molecule is absorbed, so that hydrogen molecule is converted into hydrogen atom. This hydrogen atom, उसमें क्या है? Electrons होगा. The electron present in the hydrogen atom is going to absorb energy and it excited to the lower level to higher level. That is called excitation. When you switch off this now, this higher energy level electrons are going to come down, that is called de-excitation. ये de-excitation process में जब इलेक्ट्रॉन नीचे से ऊपर जा रहे हैं ना, एनर्जी ले रहे हैं, सो ऊपर से नीचे आ रहे हैं ना, इलेक्ट्रॉन एनर्जी दे रहे हैं. सो इलेक्ट्रॉन इज गोइंग टू रिलीज एनर्जी, लूज एनर्जी फ्रॉम jumping from higher state to lower state. That you can say de-excitation process. During that, energy is released. So that energy is taken and it is passed through a prism. When it is passed through a prism, we are going to see various lines on the photographic plate. These lines are observed by the scientist. हाँ हाँ, आपका डाउट है क्या? ये टॉपिक से पूछ सकते हैं ना चटर्जी बेटा, राइट? हाँ, वेरी गुड. नाउ these lines are named by the discovery of the, yes. Okay, thank you. So these lines are named by the discovery of the scientist. इनका नाम है, सबसे नीचे वाला लाइमैन सीरीज है, बामर भी है, पैशन है, ब्रैकेट and fund. See the spellings and all pronunciation. And Humphrey, a series of lines, इसीलिए ये लाइमन सीरीज, बामर सीरीज, पैशन सीरीज, ब्रैकेट सीरीज, फंड सीरीज एंड हम्फ्री सीरीज. ठीक है बेटा? हाँ, उसमें सबसे पहले बामर सीरीज डिस्कवरी किया गया. सो बामर सीरीज इज अ सीरीज which is visible in the, which is seen in the visible region. So that we are going to see. So how these lines are formed? These lines are formed when the electron is jumping from higher level to lower level, and this picture tells you like this, है ना? Whenever electron, these are the, actually atom is a spherical, so electron revolve in a circular path according to Bohr. ये सर्किल हमारा कन्वीनियंस के हिसाब से I just drawn in a parallel line so that this is a nucleus somewhere, okay, and these are the shells. Shell number 1, shell number 2, shell number 3, 4, 5, 6, 7, like that. So when the electron is jumping from higher shell to lower shell, it loses energy, and this energy in the form of radiation gives a spectral line. When the electron is jumping from higher level to first n is equal to 2, it is going to give the spectral line. N is equal to 4, 3, passion, okay, bracket and fund, है ना? So these spectral lines are given Lyman series, this is Lyman series, Balmer series, passion series, bracket series and fund series, like that. So to get the spectral lines, electron should come from anywhere, and it is coming to n is equal to 1 to form a Lyman series. This Lyman series is formed in the UV region that I want to show you by using a tabular form. Here you can see here, yes, Lyman series, read the Rydberg equation. यह Rydberg equation आपका बोलना है. देखो, when this light is coming ना, this light gives a spectral line. This light has some kind of wavelength. ये वेवलेंथ कैलकुलेट करने के लिए आपका Rydberg इक्वेशन इस्तेमाल किया जाएगा. दैट इज न्यू बार इज इक्वल टू 1 by lambda is equal to rz square of 1 by n1 square minus 1 by n2 square. Yeah, nu bar is a wave number and lambda is a wavelength, है ना? And z is equal to atomic, z is equal to atomic number किसका? एटॉमिक नंबर किसका? ये एक्सपेरिमेंट में आप हाइड्रोजन गैस इस्तेमाल किया. सो जो भी गैस आप इस्तेमाल कर रहे हैं ना, ये गैस का जो एटॉमिक नंबर होता है, सो हाइड्रोजन एटॉमिक नंबर 1 z इज इक्वल टू 1. अगर हीलियम इस्तेमाल करो एटॉमिक नंबर 2, आप हीलियम, हाइड्रोजन, हीलियम, लिथियम इस्तेमाल करो एटॉमिक नंबर 3, बेरिलियम 4, लाइक दैट. सो दैट R is equal to Rydberg equation. Rydberg कांस्टेंट, इसका वैल्यू है 109,677.8 सेंटीमीटर इनवर्स. माय डियर स्टूडेंट्स, केयरफुली सी Rydberg इक्वेशन. ओके, ये वैल्यू जो है मैं थोड़ा सा अप्रोक्सीमेट करके, ओके, 1.0967.8. I just want to say approximate it, make it 1.1 into 10 to the power of 5 centimeter inverse. You can use this value while you are doing questions. And what is N1 beta? N1 is 2 address and N2 is from address of the electron, right beta? N1 is the to address, N2 is the from address. Now I just want to say a simple trick from my side, my dear students. Whenever Suresh Sir is saying about some tricks, it is quite useful for your NEET examination. So आप कमाल कर सकते हैं ये ट्रिक से. 1/r वैल्यू सीधा 911 एंगस्ट्रॉम यूनिट्स ले सकते हैं, क्योंकि ये 1/λ के आप सीधा लैम्डा निकाल सकते हैं 1/r से. समझ में आ रही है क्या बेटा? चटर्जी and other students, it is given in the link. You can click the link so that you will be getting a test information and you can create your own test by using these links, and you will also get updates on NEET examination and the class and examinations, and every update you are going to get when you join in the Telegram channels and all. Okay, okay, Kushwaha, right, that's good. So let's talk about Lyman series. Electron is coming. N1 का मतलब क्या? कहां तक आ रहे हैं, कहां से आ रहे हैं? That is N2 है ना. N1 is to which shell the electron is coming, N2 is from which shell the electron is coming, है ना. So Lyman series फॉर्म करने के लिए इलेक्ट्रॉन n is equal to 1 तक है आना. ये 2, 3, 4, 5, 6, 7 से आ सकते हैं. And the spectral region that is formed in the ultraviolet region. So if you write the equation, Rydberg equation or Rydberg equation, nu bar is equal to r into 1/1 square minus 1/n2 square. n2 square ये नंबर का हिसाब से दे सकते हैं. ये क्वेश्चन बोलेगा आपका ये पहला लाइन का है, ये दूसरा लाइन का है, ये तीसरा लाइन का है. डोंट लुक द नंबर्स. सो दिस इज व्हाट यू कॉल H alpha Lyman, H beta Lyman, H gamma Lyman. Are you getting or not? H alpha Lyman means hydrogen atom first line. Alpha means first line, okay, of the Lyman series. Are you getting or not? So understanding ये न्यूमेरिकल्स है ना, बिना नंबर देके ये न्यूमेरिकल्स बना सकते, ओके. उसमें आपका आएगा कैलकुलेट द Lyman series, calculate the wavelength of the H beta line of series line of the hydrogen spectrum, bus, okay. So Bohr series, this is the first series line that is observed because this is found in the visible region, and the electron is coming to 2, and this first line, second line, and this is the third line. It goes like that: H alpha Bohr, H beta Bohr, H gamma Bohr, right? Definitely Richa Sharma. When you can see here, just a minute, Anil, చెప్పు, క్లాస్లో ఉన్నా. Yes. So when you see here, this is n is equal to 1, this is n is equal to 2, this is n is equal to 3, this is n is equal to 4. Let us say this is n is equal to some infinity line, some line at from infinity, right? So I just want to form Lyman series. Lyman series means electron हमेशा कहाँ तक आना है? n is equal to 1 तक आना है. Richa Sharma, okay, okay, hi Ayush, okay, Rushan, I am explaining this again. So when the electron is coming from n is equal to 2 to n is equal to 1, so this is called H alpha line or the first line, okay, H alpha Lyman, carefully you see, H alpha Lyman. So that n1 is equal to 1, n2 is equal to 2. Hope you understand? Hope you understand? Ayush, you are a PUBG lover, not a chemistry lover, beta. Okay, Richa Sharma, you understand? Come on. So, agar electron यहाँ से यहाँ तक आ रहा है ना, n is equal to 3 से n is equal to 1 तक आ रहा है ना, that you can say beta line. Karthik, I am from infinity land beta, right? It is going to be H beta Lyman. In this H beta Lyman, you can say n1 is equal to 1, n2 is equal to 3. समझे? Right, okay. I just want to talk about here, this is what you call it H gamma, right? H gamma का मतलब क्या? H gamma Lyman. In the H gamma Lyman, electron is coming to be n is equal to 1 and n2 is going to be 4, right? Are you getting or not? Richa, fine. Now, every doubt is going to be, अगर electron यहाँ से यहाँ आ रहा है ना, so that is called series limit. इससे ऊपर नहीं आ रहे ना, right? So you can say H infinity. You can see the symbol alpha अलग है, infinity अलग है, right? So this is nothing but n1 is equal to 1, n2 is equal to infinity. You can say this is what you call it as series limit. This is what you call it is series limit. This series limit, you are going to get maximum energy and minimum wavelength. Are you getting or not? Yes, Ayush, fine. Richa, fine. That's good. At least thanks. I should say you are asking a doubt. Okay, that is what you call it as series limit. Paschen series, you can say this is first line, second line, third line, alpha line, beta line, gamma line. So if it is said that for a Balmer series, wave number is equal to r into 1 by 2 square minus 1 by n2 square. This is the n2 is the variable. ये क्वेश्चन का हिसाब से n2 वैल्यू आप खुद पकड़ना है. 3, 4, 5. Got it? Fine beta. Similarly, bracket series, infrared, nu bar is equal to r 1 by 4 square minus 1 by n2 square. Clear? Any doubt here, children? Very good. Fund series, don't pronounce as is the P fund, it is for hydrogen atom. अगर कुछ बोलेंगे तो नहीं बोलेंगे तो हाइड्रोजन मान लो. Clear? This is for hydrogen spectrum. So Z is equal to 1. I didn't write it, right? दैट्स गुड, ठीक है, फाइन. नाउ yeah, if the threshold frequency wavelength of the ejection of electrons from a metal is 330 nanometers, okay, work function of the photoelectric emission is, work function is equal to h nu naught, work function is equal to hc by lambda naught. Fine beta, fine. A 11th grade का है आयुष. Okay beta, so that 6.626 into 10 raise minus 34, h का value Planck's constant and c value is 3 into 10 raise 8 upon lambda naught दिया गया आपका 300, so that 300 nanometers मीटर से convert किया 10 to the power of minus 9, 10 to the power of minus 9, so 1 nanometer is equal to 10 to the power of minus 9 meters. So 10 to the power of minus 9 से आप करने तो आपका मिलेगा, so 3, so that you are going to get 6.626 into 10 to the power of minus 19 joule मिलेगा. ठीक है बेटा, option 3 है. Fine, that's great answer. Now kinetic energy of photoelectronic emission is independent on, yesterday I have given a graph, so intensity and the kinetic energy. If intensity kinetic energy and intensity of the radiation, if intensity of the radiation increases, kinetic energy has no effect. So intensity of the radiation increases, you are going to increase number of photoelectrons, but kinetic energy of the photoelectrons are same. So my answer is going to be 4. Clear beta, ये graph का हिसाब से. Any doubts children? Okay, Ayush, you are a PUBG lover, right? So PUBG आजकल चल रहे हैं क्या क्लास में? Okay, no doubt, that's good. The ratio of energies of photons of wavelengths 2000 and 4000 angstrom units. नहीं, okay. So इसका आंसर कौन देंगे? Okay, no doubt. Rishan, yeah, Ishita, you got fourth option? You got fourth option? Lambda is equal to hc by E is equal to hc by lambda. h constant है, Planck's constant है, c velocity of light ab constant है, so that E is inversely proportional to 1 by lambda. So E1 by E2 is equal to lambda 2 by lambda 1. सही है बेटा? मान लो ये वाला lambda 1 है, ये वाला lambda 2 होगा, है ना? So that it is 4000 upon 2000, आपका मिलेगा 2 by 1, so 2:1, right? So your answer is appreciated. Fourth option is the correct answer for this question. Okay, Ji Guruji. Okay, very good. Thank you very much for your compliments, my dear students. Let's look at this. Okay, the emission spectrum of hydrogen in the visible region consists of, who is going to, in the NEET examination, mind it, in the NEET examination you are asked to attempt the question by reading the statements, theory, सारा के सारा questions maximum 80% of the questions or 75% of the questions it's going to be theory, and you have to understanding and application oriented, understanding oriented and knowledge oriented. So theory का मतलब और रट्टा मारना, न्यूमेरिकल का मतलब वो मैथमेटिक्स पकड़ना, ऐसा नहीं बेटा. नीट एग्जामिनेशन very important, you have to work on the standard procedure of reading the questions from the concept oriented and object oriented. It's a pure multiple choice question objective type का है. Okay, आयुष में कर लेता हूँ, IIT भी कर लेता हूँ, ठीक है. सो नाउ वी आर इन द नीट 2025 स्टेप अप प्रोग्राम. हियर मेडिकल एंट्रेंस के बारे में बात करना ठीक होगा. सो इसका ये कंटिन्यूस बैंड ऑफ लाइट, ना 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 ना, हाइड्रोजन इमिशन स्पेक्ट्रम इज एन एटॉमिक स्पेक्ट्रम, इट्स ए लाइन स्पेक्ट्रम एंड इट इज डिसकंटिन्यूस लाइन स्पेक्ट्रम होना है. सो सीरीज ऑफ इक्वली स्पेस्ड लाइन्स, ना 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 ना, व्हेन यू सी द space between the line and line alag hoga. So series of lines that are close to at lower energies and series of lines that are closer at higher energy. See, a khatarnak question hai. You see, this question gives a lot of discussion in the hydrogen spectrum. It is about a series of lines that are closer at higher energy. इसका मतलब क्या? इसका मतलब क्या? देखो आपका है, हाँ, जस्ट सी, right. When I show this particular hydrogen spectrum diagram, this is the N1 and N2, shell number 1 and shell number 2. Shell number 6 and shell number 7. Shell number 1 and shell number 2, ये पहला दो शेल्स है ना, ये जो शेल का अंतर देखो, N1 to N2 इतना गैप है, N6 to N7 इतना कम अंतर है. Are you getting or not? Understanding and observation of the diagram is also important in the competitive examinations, my dear students. So ये डायग्राम के हिसाब से आपका ये क्वेश्चन कर सकते हैं ना. सो लुक एट दिस, ये सीरीज ऑफ लाइंस दैट आर क्लोजर एट अ हाई एनर्जीज. सो दिस इज N1, दिस इज N2, N3, N4, N5, N6, N7 and N8. You can see as you go high they are closer. Are you getting or not? So that is the meaning of the statement here. It is a theory. Yeah, ready to play? Okay, come on. So आगे बढ़ना, calculate the series limit of a Lyman series. ये series limit क्या? I just want to ask somebody, what is series limit? Come on, Richa, बोलना series limit क्या? Series limit का जब series limit आ रहे हैं ना, N2 is equal to आप infinity मान सकते हैं. Right. So whenever it is a Lyman, it is going to be N1 is equal to 1. Right? So hydrogen atom, it is Z is equal to 1. Z is equal to 1. So that's, this is a question, is actually a numerical. This is actually a numerical. ये numerical में कम से कम number नहीं दिया. So calculate the wavelength. So 1 by lambda, here I just want to do it here, 1 by lambda is equal to RZ square upon of 1 by N1 square minus 1 by N2 square. है ना? Right, उसमें 1 by lambda is equal to, don't put R value, keep the R value there only. R value there only. Richa, you said infinity. Ishita, where are you? I can't see your comments, I can't see your doubts. Ishita, come on. Don't retract your message, it is infinity. So series limit means it is infinity only. Infinity, numerically we are doing from infinity learn. बहुत बढ़िया बात है. Okay, so hydrogen Z is equal to 1 square minus 1 by infinity square. Okay, 1 by infinity square is equal to 0, right? So 1 by 1 square is equal to 1, 1 minus 0 is equal to 1, right? So that 1 by lambda is equal to R. समझे बेटा, समझे बेटा. So lambda is equal to 1 by R, है ना. सुरेश सर एक ट्रिक दिया था, क्या है ट्रिक आपका, पीछे जाओ. सुरेश सर हमेशा ट्रिक्स देते हैं ना. मेरा ट्रिक के हिसाब से 1 by R is equal to 912 एंगस्ट्रॉम मिनट्स और 911 एंगस्ट्रॉम मिनट्स, कुछ फर्क नहीं पड़ता आपका. सो आप मान लो 911 एंगस्ट्रॉम मिनट्स, ये 911 एंगस्ट्रॉम मिनट्स. सो विदाउट सॉल्विंग मेरा ट्रिक इस्तेमाल करके आप सीधा आंसर बोल सकते हैं ना. कमाल किया ना, है ना. क्लियर चिल्ड्रन, एनी डाउट हियर? दिस इज वेरी इंपॉर्टेंट. हाँ, right. Now, Bohr's atomic theory. I love him. He's such a smart scientist. Bohr कुछ नहीं किया बेटा. Bohr was actually a deputy or say student of Rutherford. Okay. So मैं Rutherford में क्या बोला? Rutherford said electron revolve around the nucleus like this, but people observed that अरे electron ऐसा घूम रहे हैं ना, so it should take a spiral path and fall into the nucleus. This is the first defect. This is the first defect. So against to that, Bohr corrected that theory. Na. It is electron revolve around a perfect circular path. He proved that it is a circle. Path is circle. अरे सर्किल बोलने के लिए रेडियस कैलकुलेट करके दिखाना यार. ही कैलकुलेटेड द रेडियस मैथमेटिकली. सो जो भी किया रूदरफोर्ड, ओके, ये थ्योरी से थोड़ा सा करेक्शन किया. सो दैट मच फेमस साइंटिस्ट ही इज. ओके, even you have a periodic table, he just only corrected the periodic table, and we are using the periodic table designed by Niels Bohr, right? He corrected many things, and simply he is associated with Rutherford and Einstein, Max Planck, and he made his own theory by is a theoretical physicist, right? Okay, G, right, clear. So Niels Bohr proposed his atomic model based on photoelectric effect and Planck's quantum theory. Two theories he considered. According to that, jaldi postulates of Bohr's atomic model: electron revolve around the nucleus in a concentric circular path called orbit, है ना? So this is the orbit. ये concentric circles क्या? सभी circles का एक ही nucleus आता है. So they are given as K shell, L shell, M shell, N shell, like that. मेरे बचपन से एक एक क्वेश्चन है मेरा, my dear students here, why it is not given ABC cells, why it is not given XYZ cells, why it is started with K, L, M, N? If anybody knows the correct answer, you just put in the comment box. I would be very happy, right? And if you make any comment, I am going to reciprocate that comment with a proper answer. Right, beta? So electrons in an atom revolve around the nucleus with a definite velocity in a certain fixed closed circular paths called orbit, and these shells are given numbers also. K is equal to 1, L2, M3, like that, right? Okay, clear, right? So here I just want to say, when the electron is revolving around the nucleus, it has radius and it has a velocity, it has the mass. So this is what you call it as angular momentum. that is mvr. So you have momentum mv in a linear path, angular momentum mvr for a circular path. This is equal to n dot h by 2 pi. So what I want to say, n is an integer here, n is an integer, shell number, n could be 1, 2, 3, 4 and it goes on. mvr is equal to thank you very much, n is equal to a shell number. अगर एक k shell में इलेक्ट्रॉन घूम रहा है ना, k shell, l shell, m shell, n shell, इसका mvr is equal to 1h by 2 pi, so that h by 2 pi. L shell में mvr is equal to 2h by 2 pi, h by pi. So m shell में mvr is equal to 3h by 2 pi, 3h by 2 pi. So 1.5h by pi. हाँ, thank you Ayush. n shell में mvr is equal to 4h by 2 pi, so 2h by pi. So मैं क्या बोलना चाहता हूँ, that electron revolve अलग अलग shell में अलग अलग angular momentum होता है. So that electron will have a fixed amount of, definite amount of energy, definite value of the velocity with a definite radius and definite angular momentum. Everything is well defined and it cannot be more than that, it cannot be less than that, right beta? G, correct. Okay, so that atom is said to be stable if its value is fixed. So angular momentum value of an electron in an atom is always fixed. इसका magnitude fixed है, so यही है magnitude का value है. So this is quantity is fixed. You can say it is quantization of angular momentum, and this quantization of angular momentum is the strongest point in the Bohr's atomic theory. My dear students, is very important. Okay, each stationary state is associated with definite amount of energy. So when electron is revolving around the nucleus, अलग अलग shells में अलग अलग energy values होना चाहिए. Okay, that's you want to say. So as long as electron revolve around the nucleus in a particular shell, the electron neither lose nor gain energy. इसका एनर्जी हमेशा कांस्टेंट है. बट इलेक्ट्रॉन है ना जो बच्चे का जैसा है, ओके, it gives the energy it takes, okay, it goes up and it come back by loss of electron. Yes. Thank you very much. Right. So you just join the Telegram channel, Ayush beta. You can join in the Telegram channel, you will get more updates on that. You can ask doubts in also, right? Okay, come on. So energy of electron changes when electron jumps from lower energy to higher energy, it absorbs, and it jumps from higher energy to lower energy, it releases. So that released energy, so it can absorb and release, and it can change the energy values. So अगर मान लो इसका एनर्जी E1 होगा, इसका एनर्जी E2 होगा, ये दोनों का अंतर है ना, that is in the form of radiation. delta E is equal to hc by lambda is equal to E2 minus E1 भी हो सकता है. That's what I want to say. Yes, E2 minus E1 is equal to delta E is equal to h nu. So this is simplified version. So if energy is gained, E1 is the lowest energy shell का energy है, E2 is the highest energy shell का energy है. So that nu, this is nu is equal to delta E by h, that is E2 minus E1 upon h. Okay, you can calculate these things like many. This is called Bohr's frequency rule. This formula is known as Bohr's frequency rule. Okay, so any doubt, my dear students? Make an interaction. Any doubt, you can ask a doubt so that we can discuss. आगे बढ़े आज. Very good. So I am teaching so that no doubt. Ishita, thank you very much. So centrifugal force of the revolving electron in a stationary orbit is balanced by the electrostatic attraction between the electron and the nucleus. You can see here, this is a circular path nucleus and this is electron. है ना? So that electron is moving. When the electron is moving, this is your tangential velocity, and so nucleus is always asking the electron, you come and fall into this. So electron मना कर रहे हैं, so that opposite force आ रहा है ना. So there should be two forces, one is towards the nucleus, one is away from the nucleus. The force which is towards the nucleus is centripetal force and the centrifugal force. है ना. सेंट्रीपेटल फोर्स इज इक्वल टू सेंट्रीफ्यूगल फोर्स में क्या बोलना चाहता हूं, राइट. सो यू कैन से दिस इज mv square by r minus kze square by r. So that is a electrostatic forces. So centripetal force का है. So that kze square by r upon mv square by r. So this goes with the derivation and energy calculate कर सकते हैं, radius calculate कर सकते हैं, velocity calculate कर सकते हैं. But एक classical physics का हिसाब से we don't want to derive anything here because NEET examination में ऐसे derivation का chance भी नहीं है ना. Right, game over, good night. Okay, now let's talk about radius of hydrogen atom. So this is your hydrogen atom, nucleus and the electron. ये बीच में अंतर कितना है? So Bohr calculated this radius as 0.529 into z by into n square by z. So that is derived from radius of nth orbit is equal to n square h square upon 4 pi square m e square, and these expressions are important as multiple choice question in the NEET examination, my dear students, right. So Rn is given as radius of nth shell 0.529 into 10 power minus 8 into n square by z. Z is atomic number 1819. Okay, Ritika Mishra. Hello Ritika Mishra. This is class. Okay. Okay, come on. And radius of nth shell is going to be 0.529 into n square by z angstrom units. ठीक है बेटा. So this is to calculate in centimeters, this is to calculate angstrom units. 1 angstrom unit is equal to 10 to the power of minus 8 centimeters, right. Okay, Suresh, okay, very good. Energy of the electron is also calculated. Energy of the electron is equal to, my dear students, energy of the electron in the atom is negative. In the atom is always negative. Electron energy at rest is going to be 0. Electron, when it is moving by its own outside the atom, इसका energy positive होना है. So that energy of the electron inside the atom when it is revolving around under the influence of the nucleus should have the less energy than the electron's energy at rest. Therefore, electron's energy is taken as a negative. ठीक है बेटा. So that its energy of the electron इसका action है and derivation के हिसाब से मिलेगा. Okay, don't have to derive it. That is 2 pi square m e to the power 4 upon n square by h square. Different units, different values में. Okay, bromine 6 oxygen and fluorine size different, not much, but the electron affinity have the huge different. Why? Hey, bromine, what is this? Because of the fluorine has extremely small size, incoming electron is going to be make the repulsion, so that electron has to be incorporated by expending some amount of energy, so that when you calculate the overall energy, the energy overall released should be deducted by the energy expended, so that फ्लोरीन वैल्यू एंड ऑक्सीजन वैल्यू बीच में कुछ डिफरेंस आएगा. ओके, ब्रोमीन, दिस इज नॉट द करंट क्लास ऑफ डिस्कशन, नाउ विल डिस्कस इट लेटर, राइट. ठीक है. नाउ टॉकिंग अबाउट एनर्जी ऑफ द इलेक्ट्रॉन इज कैलकुलेटेड -2.18 into 10 power -11 by n square erg per atom. ठीक है. And this is very important, this is very important. And -2.18 into 10 to the power of -18 upon n square joule per atom, right? That's good. And this is also very important, 13.6 into 13.6 upon n square electron volt per atom. 1 electron volt is equal to 1.6 into 10 power -19 joules. अगर आप कैलकुलेट करने का वक्त में ऐसे करने तो अच्छा होगा. ओके, ना केवी why does the electrostatic force with centripetal force? Actually, the centripetal force and centrifugal force should be equal and opposite sign, so that electrons path is going to be in the direction of tangential velocity, so that electron will be tangled within the atom, otherwise electron would have gone out of the atom. है ना बेटा केवी, राइट. सो अगर ये किलो जूल्स में देना, अगर ये किलो जूल्स में देना चाहता हो तो ये फॉर्मूला इस्तेमाल करो, किलो जूल पर मोल. These units are important. In this particular slide I just given emphasis on units, mind it. So यूनिट्स के हिसाब से अलग अलग फॉर्मूलास बना के आपका तैयार रख दिया मैं. ठीक है बेटा, चलो. कैन आई क्लियर दिस? इज वेरी इंपॉर्टेंट. इशिता, इट्स वेरी इंपॉर्टेंट. एक बार स्नैपशॉट लिख लो, जस्ट 3, 2, 1. फाइन बेटा, फाइन. नाउ okay, these are the different one. So actually it's very important. Electron reside inside the atom. So the atom has an electron, it has energy, it has energy. The energy, total energy is sum of the potential energy and kinetic energy. Potential energy means energy due to stability, and kinetic energy is the energy due to movement. So when the electron is moving away from the atom, so it moves slowly. So it moves slowly means potential energy बढ़ जाएगा. Okay, kinetic energy कम होगा. So as the energy is coming to the nucleus, towards the nucleus, kinetic energy बढ़ जाएगा, potential energy कम होना है. So total energy is the sum of potential energy and kinetic energy. So total energy is given as minus k z e square by 2r. Kinetic energy is equal to k z e square by 2r. अरे दोनों है क्या? Yes, it is same. Total energy and kinetic energy are same, but total energy negative है, kinetic energy value positive है. So total energy value हमेशा नेगेटिव है, पोटेंशियल एनर्जी हमेशा नेगेटिव है, काइनेटिक एनर्जी हमेशा पॉजिटिव है, ख्याल में रखना. सो एंड पोटेंशियल एनर्जी काइनेटिक एनर्जी से डबल होना चाहिए. ओके, टोटल एनर्जी से डबल होना चाहिए, सो दैट के जेड ई स्क्वायर बाय आर. So this is the खतरनाक formula you can use in the physics as well. Total electron का total energy is equal to potential energy by 2 is equal to minus kinetic energy. ठीक है सर, अभी बोला ना kinetic energy हमेशा पॉजिटिव है, ये वैल्यू बदलने के उस तरफ जाके पॉजिटिव होगा ना. अंडरस्टैंड और नॉट? क्लियर? दैट्स वेरी वेरी इंपॉर्टेंट. यू कैन यूज दिस फॉर्मूला इन फिजिक्स एज वेल. वेरी इंपॉर्टेंट, वेरी इंपॉर्टेंट. ठीक है, एक बार स्नैपशॉट लिख लो. हाँ, यस, राइट. ओके, टीई इज इक्वल टू पीई बाई 2 इज इक्वल टू माइनस के ई, है ना? राइट. So derivation of Rydberg equation that we discussed. So nu bar is equal to 1 by lambda is equal to r z square upon 1 by n1 square minus 1 by n2 square. R z, this is your Rydberg constant का expression है. 2 pi square m e to the power of 4 upon c h cube. According to Bohr, the electrons revolve in energy levels which is stable, but it is possible by any chance the electron collapse within the nucleus. My dear students, you simply join the class and you are firing with questions. Anyways, appreciate it. कम से कम आपका शुभ नाम भी बोलना है. You please introduce yourself. And this is Suresh, Avari, Faculty of Chemistry from Infinity Learn. Here Z is not included. मान लो Z is equal to 1 for hydrogen. For this, okay. For your question, my dear students, who is said it is bromine, electron maintains minimum distance with the nucleus, that is 0.529 angstrom units. इससे कम distance नहीं कर सकता. If that is the case, Heisenberg uncertainty principle में infinity होगा इसका position का probability, है ना. So that we can't do. Electron do not stay in the nucleus. You can prove by using Heisenberg uncertainty principle. Okay, anyways, let's go here. So R value 2 pi square m e to the power by c h cube, खाली ये पकड़ के आपका MCQ बना सकते हैं. Substituting the values, R value 109,677.8 और 678 सेंटीमीटर मिलेगा, है ना. That's good. Now the value of almost equal to Rydberg constant is 109,677. Okay, the frequencies of the electron spectral lines in the hydrogen spectrum is calculated by using Bohr's equation in excellent agreement with the experimental values. Okay, so Bohr did not do any experiment. Okay, जो बामर दिया, जो लाइमन दिया, इन लोगों का लैब जाके बोर ये फोटोग्राफिक प्लेट पकड़ के वैल्यूज नोट किया गया. एंड रुदरफोर्ड एक्सपेरिमेंट, those experimental values Bohr has taken and he made his own theories, and theoretically Bohr calculated, and these values are getting good agreement with जो experiment किया गया. Okay, right. So this is frequency का. Frequency of the spectral line can be calculated by using 3.29 or 3.3 into 10 to the power of 15 into 1 by n1 square minus 1 by n2 square. Simply you can use from wavelength, you can calculate the wave number, you can calculate frequency also. Now calculation of velocity of the electron. Yes, electron moves with high velocity. How much velocity? ये फेरारी कार का जैसे नहीं, लाइट वैल्यू का नज़दीक में जाना है. सो दैट इज 2.18 इंटू 10 पावर 6 मीटर्स पर सेकेंड, इतना दूर जाना है. ओके, इतना स्पीड में. वी वेलोसिटी ऑफ द इलेक्ट्रॉन इन nth shell is given as nh by 2 pi mr. mvr is equal to nh by 2 pi. So velocity is equal to nh by 2 pi mr. Okay, so that velocity अगर कैलकुलेट करने तो 2.18 into 10 to the power of 8 upon n centimeter per second, 2.18 into 10 power 6 meters per second. Okay, so 100 kilometers difference में light velocity इतना तेज चल रहा है वाला. So that number of revolution, this is a very important formula from the Bohr's atomic model. You all maintain the cheat sheets for physical chemistry. So before you go for examination, you just follow the cheat sheets and you can do excellent good marks in NEET 2025 examination. My dear students, yeah, near to see. Okay, who is that name of the student NEET 2024? I request by the students, you please maintain your own name so that we can have a kind of good interaction between you and me. right? So, number of revolutions when the electron is revolving around the nucleus, how many number of revolutions it is making per second. So, that is 6.55 into 10 to the power of 15 into z square by n cube. So, number of revolutions is directly inversely proportional to the n cube times. Okay. These many number of revolutions per second means, can you imagine, near about 10 to the power of 15, more than that revolutions is making. Cut 3, yeah, doubts? Aditi Patel, we will discuss when we talk about the de Broglie wavelength. Okay, fourth orbit, de Broglie wavelength, fourth orbit, है ना? You just ask that doubt, we will discuss it. Katri Tabasum, what's your doubt? Okay, let's go ahead. We'll talk with the de Broglie wavelength. As we are in the Bohr's atomic theory, we need to discuss up to here, right? Right. Now, so time period for the revolution, it is circumference of the orbit upon velocity of the electron. Circumference is equal to 2 pi r and velocity of the orbit is, yes, clear, thank you. So, it is equal to 1.5 into 10 to the power of minus 16 into n cubed by z square. So, 10 to the power of minus 16 times of a second, it completes the make a revolution. You see how speed it is going on. Awesome. It's an awesome experience that how the electron is behaving, my dear student. Okay? Now, let's talk here. Explanation of hydrogen spectrum we already discussed. So, Bohr's theory successfully explains the formation of various spectral lines. Okay? He re-explained, we already did it. So, when the electron is jumping from higher energy state to lower energy state, it jumps and directly it can come, indirectly it can come. So, the maximum number of possible spectral lines are given as n2 minus n1, n2 minus n1 of n2 minus n1 plus 1 by 2. Okay. So, n1 is a lower energy shell and n2 is the higher energy shell. That's a very, very useful point. Okay. When if the electron comes back from energy level which has energy E2 to E1, then the difference may be expressed as E2 minus E1 is equal to delta E is equal to h nu. We did this one, right? So, this is a hydrogen spectrum. In this, electron is jumping from any state to n is equal to 1, that is a Lyman series, any state to n is equal to 2, that is a Balmer series. Like that we already made a discussion. So, Bohr's model explains the stability of the atom. The electron revolving in a stationary orbit does not lose energy, hence remains in the orbit forever, so that it is stable. So, main emphasis is given for the stability. What is the major postulate of the Bohr's atomic model? It is quantization of angular momentum. Right, beta? Suraj Rajput, I think you are from Punjab, am I right? Komal Kaushik, you said someday, some student said, right? Okay. These are the advantages. Bohr's theory, yes, that's good. So, Bohr's theory successfully explains the atomic spectrum of hydrogen. So, these are the very important points. If you say Niels Bohr and Rutherford failed to explain the stability of atom. Rutherford fails to explain the spectrum. Now, Bohr, he explained the stability, Bohr explained the spectrum. That is the difference between these two, right? Now, one more. This theory explains hydrogen spectrum, but also the spectra of one electron species. When it comes to the defects, Bohr's atomic theory is only applicable for one electron species, right? For multi-electron species, Bohr's atomic theory is not at all applicable, right? So experimentally determined frequencies are matching with the theoretically calculated frequencies by Niels Bohr. Okay. The value of Rydberg constant for hydrogen from Bohr's equation tallies with the values determined experimentally. That's an outstanding outcome. So it is true. Once it is theoretically calculated, matches with experimentally calculated, so it is true, right? This theory is true. And limitations of Bohr's theory. In the limitations of Bohr's theory fails to explain the spectra of multi-electron species, right? And he could not explain the fine spectrum. What is the meaning of fine spectrum? You have a Lyman, Balmer, Paschen, bracket, Fund series. Na? These series lines, when it is observed under microscope, you are going to get multiple lines in that. That is called fine spectrum. So Bohr's theory failed to explain the fine spectrum of hydrogen, and he cannot explain Zeeman effect and Stark effect. So when this spectrum is observed under strong electric field, the spectral lines are splitting or broken, it is called Stark effect. If the same is happened with the magnetic field, that is called Zeeman effect. So Bohr failed to explain Zeeman effect and Stark effect. Okay, and in the limitations, Bohr theory predicts the definite path of revolving electron. It is against to the wave nature of electron. So electron has particle nature as well as wave nature, but wave nature Bohr's theory is not supporting. But wave theory also working, and Bohr's theory again got a good agreement with the de Broglie. We are going to discuss in the further classes. So Bohr's theory is not good agreement with the Heisenberg uncertainty principle, which we will discuss in later classes. Okay, it could not explain the ability of atom to form molecule. So Bohr's theory cannot explain phenomena of chemical bonding. That's one more defect. Okay, so we'll discuss some more topics in the next class. My dear students, today we discussed extensively about Bohr's atomic theory. I have a class right now, so I need to force to complete this. So we completed Bohr's theory, we started photoelectric effect and recaptured and discussed hydrogen spectrum and various spectral lines, Rydberg equation, Rydberg constant, Bohr's theory, Bohr's energy, quantization of angular momentum, energy, radius, velocity, revolutions, time period, and disadvantages of Bohr's, advantages of Bohr's theory. And in the next session we are going to discuss, and means next Monday, quantum mechanical model of the atom. And tomorrow we will be discussing about second year organic chemistry, grade 12, haloalkanes and haloarenes. So hope you all enjoyed my session with a lot of energy. Okay, hope you understood. If you have any doubts, put in the comment box. Okay, you can do the best. Okay, thank you. Fir milenge kal. And I am signing off. Suresh from Infinity Land. Bye bye. Thank you.